In this lesson, we're going to look at how we can use the addition formula to rewrite expressions that involve 2 alpha. Now, these formulas here are given in the formula sheet, and they're called the double angle formula, and that will become clear as I go on with this lesson. We can use these for all sorts of techniques, and particularly to substitute in to solve equations, and again we'll look at that later on. But the first thing that I'm going to do is I'm going to show you how we get to these expansions. So the main thing we need to remember to do this is remember that sine squared alpha plus cos squared alpha equals 1. We don't need to use alpha here. You could use x or y's or anything like that, but we're just going to stick with the alpha at the moment. So I'm going to prove the cos 2 alpha first here. Now there's 3 formulas to prove. The first thing we need to understand is that we can represent 2 alpha as alpha plus alpha. Once we've done that, we can say that cos 2 alpha is equal to cos of alpha plus alpha in brackets, because these are the same things. Now that we've done that, we can use the addition formula to expand this. So it's going to be cos, cos, sine, sine with a takeaway. So cos, cos alpha is cos squared alpha, really. Take away sine squared alpha, and we've proven the first expansion here at the top. Now we're going to use that to get the second 2 expansions. So there's 2 ways to go with it. And the way to do this is to remember this idea here that sine squared alpha plus cos squared alpha equals 1. Rearranging that, we can see that cos squared alpha is equal to 1 minus sine squared, and sine squared is equal to 1 minus cos squared alpha. So we're going to use that technique here. So this can just be written as cos squared alpha minus 1 minus cos squared, because we can rewrite sine squared as 1 minus cos squared. Multiplying at the brackets, you're going to have take away 1 plus cos squared, which is going to give you 2 cos squared take away 1, which is this formula here. And the same token, we can represent cos squared with 1 minus sine squared. So then you're going to get 1 take away 2 lots of sine squared alpha, so that's going to look like that, which is this here. And I've not done it here, but it's easy enough to do this in the same manner. If you do sine alpha plus alpha and expand it, you're going to get sine cos plus cos sine, and that's 2 lots of sine cos really, which gives you this. Right, let's look at this here. Some easy examples to start us off. So it says write cos 12x in terms of cos 6x and sin 6x. Now if we look at the formulas again, the reason it's called the double angle formula is because if we have a single angle here, 1, then over here we have 2 of them. So we double up on the angle, so that means if we have, say for example, we had a 3 here, 2 sine 3 and cos 3 alpha, then this would be sine 6 alpha. And so on, 2 sine 8 alpha and cos 8 alpha would be a 16 sine 16 alpha, so this doubles up on this side. Or you could look at it as halving to get here. The same thing happens with this. For every angle on this side, to get this one you double it. So the cos of 2 alpha is equal to cos squared alpha minus sine squared alpha. But the cos of 4 alpha is equal to cos squared 2 alpha, take away sine squared 2 alpha. And cos of 8 alpha is equal to cos squared 4 alpha, take away sine squared 4 alpha. And that's the reason it's called the double angle formula, because you're doubling the angle on this side or halving it on the other side. So if we want to write cos 12x in terms of cos and sine, we have to choose which one of these represents cos and sine, and that would be the top one here. So cos 12x is going to be equal to cos squared 6x minus sine squared 6x here. So that's to double the angle, and this side's half the angle. If you just wanted to write it in terms of just sine, then you'd look for the one that we can change it to just have a sine in it, and that's the bottom one. So it's going to be 1 minus 2 sine squared 6x. Notice that the 12 goes to a 6 again. Nothing else changes. It's just the angle that you're halving or doubling. And finally, we can reverse the process. This we've got one like looks like the top. We've got 2 sine 4a cos 4a. And we've got to write it in terms of the sine 2 here. So what's happened is we've got a 4 here in front of these parts, so that means that must be an 8 here. So that would be sine of 8a.